Imagine building a highway system. Would you want every single car to negotiate its path individually, or would you set up clear, predictable routes for certain crucial journeys? In the complex world of computer networks, administrators face a similar decision when guiding data packets to their destinations. Static routes are preferred over dynamic routing in specific, carefully chosen scenarios where simplicity, security, and predictability are paramount. These are situations where network topology is stable, changes are infrequent, and control over routing paths is a top priority. Conversely, dynamic routing shines in larger, complex, and frequently changing environments. The fundamental difference lies in how routers learn paths. Static routes are manually configured by a network administrator. You explicitly tell a router exactly where to send traffic for a particular destination, creating a fixed and changing path. There is no overhead from route advertisement protocols, and the path remains constant unless you manually change it. Dynamic routing, on the other hand, involves routers automatically exchanging routing information with each other using specialized protocols like Open Shortest Path First, or OSPF, and Border Gateway Protocol, or BGP. These protocols allow networks to discover new paths, adapt to outages, and find the most efficient routes in real time. Static routes offer less flexibility but provide absolute control and consume minimal router resources, making them ideal for precise applications. So how do you decide? You should strongly consider static routes when connecting to a stub network, which is a network with only one entry and exit point. Here, there is no need for complex dynamic routing protocols to discover multiple paths, as only one option exists. Another key scenario is for small, stable networks where the number of routes is minimal and changes are rare. This eliminates the overhead of dynamic protocols entirely. Furthermore, static routes are excellent for security, as they do not broadcast routing information, making a network less susceptible to certain types of attacks. They can also serve as a crucial backup mechanism, acting as a last resort route when all dynamic paths fail. Finally, for very specific traffic engineering, where certain data must absolutely follow a predetermined path, static routes provide the precise control needed. Understanding the concept of administrative distance helps clarify this. Each routing method, whether static or dynamic, is assigned an administrative distance, which is a numerical value indicating its trustworthiness. Static routes typically have a very low administrative distance, meaning they are highly trusted and preferred by a router if a dynamic route to the same destination also exists. This allows static routes to override dynamic routes for specific purposes, providing a powerful tool for network administrators to assert control and implement specific traffic policies. For instance, you could configure a static route for a critical application to always use a specific, reliable link, even if a dynamic protocol suggests a slightly faster but potentially less stable path. Choosing between static and dynamic routing is not about one being inherently better than the other. It is about selecting the right tool for the right job. By carefully evaluating network stability, security requirements, and desired levels of administrative control, network engineers can implement routing solutions that are both efficient and resilient. This strategic choice ultimately leads to a more optimized, secure, and reliable network infrastructure, ensuring data flows exactly where and how it should.
If you love understanding how the web works, like, subscribe, and stay connected with us.